Hello, eighth grade. Today we're going to work on simplifying rational expressions, and we're going to use factoring to do that. So you're going to have to kind of refresh your memory on factoring from when we worked with polynomials and quadratics. So first of all, let's think about what it means to be a rational number. A rational number is any number that can be written in fraction form. So 2/3 is a rational number because it is possible to do 2 divided by 3 and get a decimal number from it. A rational expression happens when you have a variable in the denominator. So this would be considered a rational expression. So rational expressions are considered simplest form when there are no common factors in the numerator and denominator other than 1. Just like on a fraction, the idea is the same, that we can simplify any kind of rational expression if there is a common factor. So let's look at this rational expression. Right now, it's hard to see the common factor because they're not in factored form. So let's take this numerator of 6x plus 12 and let's factor out a common factor of 6, and then you're left with x plus 2 over x plus 2. Now you have to remember that x plus 2 in the denominator is a factor altogether, right? It's not separate. It's not an x and a 2. It's a quantity of x plus 2. And so now we have a common factor of x plus 2, so we could simplify this to 6. So this is a case where we have monomials as the numerator and denominator. So we can just sort of separate the coefficients from the variable. And so we can simplify the coefficients and simplify the variable. And so the coefficients have a common factor of 5, and the coefficients have a common factor of b. And so we are left with 3 in the numerator and 5b in the denominator. Now here's a case where we have a monomial in the numerator, but a binomial in the denominator. So we need to find a way to factor that binomial, which we can. You can see that there is a common factor of 3 in each of the terms. So we could factor out the 3, and we're left with c minus 2, and then we have 12c squared on the top. Now, that this is a factor, c minus 2, right? There is no c minus 2 in the numerator to factor that with. But now we could think about the 12 and the 3. And so you could factor out a 3, and so we're left with 4c squared, and we're dividing that by c minus 2. So in this problem, we need to look for factoring opportunities so that we can simplify. So I see on the top that there's a common factor of 2. So we have 2m minus 1, and then there is 2m minus 1 here. And you can see by adding the parentheses, I make that a little clearer to see that those are common factors. And so we could simplify that to just 2. Okay, so we'll step it up a little here in complexity. So we have a binomial and then a trinomial. And so let's factor the binomial. I see a common factor of 2 here. And so now I need to factor this trinomial. So I'm looking for a product of 6 and a sum of -7. And you know, one thing to always think about is that if there is a quantity here, there's a good chance that quantity might be one of the factors. And in this case, I believe it is. So x minus 1 times x minus 6. And now, hopefully you can see that those two x minus 6's will factor away, because when you divide them by each other, you get 1. So we're left with 2 in the numerator and x minus 1 in the denominator. All right, let's try this one. And if you want to pause the video, do it yourself, and then come back and see if you got it right, that's perfectly fine with me. So I see I can factor out a 3 here. So we're left with x plus 4, and I'm guessing x plus 4 is one of my factors. And that would make this x minus x minus 5. X, I'm having trouble writing at the moment. X minus 5. So those two x plus 4's factor away. You're left with 3 divided by x minus 5. And that is correct. So let's take a look at this one. We have a quantity of x minus 3 divided by 3 minus x. So what you can see is these are opposites. In the numerator, we have a positive x and a negative 3. In the denominator, we have a negative x and a positive 3. So what we can do here is we can factor out a negative 1 from the denominator. So if we say that if we factor out a negative 1 from the denominator, that would leave negative 3 plus x, which is what we have in x minus 3, right? We could reverse those two quantities, those two terms, and it would be negative 3 plus x. And so this really does simplify with this, and we're left with negative 1. Okay, let's give this one a try. I see that I can't factor out a 5 in the numerator. And then if we were to factor this, it kind of looks like a difference of squares, doesn't it? 3 minus x times 3 plus x. I believe that would do it. But it seems like we should be able to simplify something, doesn't it? Well, here's where that factoring out a negative 1 would help. We need an x minus 3. Well, where can we get that? If we factored out a negative 1 from this term, that would leave us with negative 3 plus x, which is the same as x minus 3. So now this and this. So we have factored out the negative 3 plus x and the x minus 3, which are the same. And what are we left with? Well, we have this negative here, which means the whole thing is going to be negative. We have a 5 on the top, and we have 3 plus x on the bottom. So it's the opposite of 5 divided by 3 plus x. Let's try another one of these, because these are a little bit confusing. When you have an x and a 4 and an x, and one's positive, one's negative, and then the others are the opposite, you've got to know that there's that negative 1 option. So I would apply it to the bottom. If we do negative 1, we would have to multiply this by negative 4 plus x. And negative 4 plus x, if we reversed these, would be x plus x minus 4. X minus 4, which is the same thing as what we have on top, and then we're left with negative 1. So this would simplify to negative 1. I know that might be a little bit confusing. All right, let's try one more together. What I see right away is that we have difference of squares on the bottom. So m plus 8, m minus 8. M minus 8. Okay, and then we have, I'm going to turn this around and see if that makes it a little easier for me to see. Negative m plus 8, same as 8 minus m, just reverse the terms. Okay, so now we don't have a common factor right now, but we could create one by multiplying one of those factors in the denominator by negative 1. If we multiply this one by negative 1, we end up then with the same factor that we have in the numerator. So this and this are going to simplify away, and we have a negative on the bottom, so it's the opposite of, and we have an m plus 8 on the top. Okay, so you have some practice in your workbook or your math book to give it a try, and let's see how you did. All right, see you later.